Good morning, welcome to
MathForKids number 158.
158, and 8 is really... Okay, yesterday we talked about the Pythagorean theorem in Math for Kids number 157, right?
Yeah.
And we learned that, what did the Pythagorean theorem say?
A squared plus b squared is c squared for sides of a triangle.
No, not for sides of a triangle.
A right triangle.
For sides of a right triangle. We have sides of a right triangle are a, b, and c, then we have a squared plus b squared equals c squared. And this is probably one of the most famous theorems in all of mathematics. And what this allows you to do is, if you know two sides of a right triangle, what can you find?
The third side.
You can find the third side. For example, if a right triangle has sides 6 and 8, let's try to find the third side. What do we usually call the hypotenuse?
We got x.
Well,
or c.
C. I don't know why, but for geometry we'll call it C. That's what they do. I don't know why. Who knows why? Could be any reason. Okay, so what does the Pythagorean theorem tell us for this triangle?
Well, 6 squared plus 8 squared is c squared.
6 squared plus 8 squared equals c squared.
Well,
okay.
6 squared is 36.
6 squared is 36.
8 squared is 64.
8 squared is 64.
So 36 plus 64 is 100.
Okay, 100 equals c squared.
So c is 10.
So c equals 10. Okay, well that worked out real nice.
Yeah.
Okay, so if, for example, if you have a room, you're in a room, and one of the walls is 6 feet long and one of the walls is 8 feet long, that means if you walk from one corner to the other corner, you'd walk 10 feet. Pretty neat, right? Mm-hmm. But it doesn't always work out to be so nice. Why don't you just give me two numbers for the length of the sides?
How about 11 and 13?
Okay, 11 and 13. Let's see how that works out. So we have 13 squared plus 11 squared equals c squared. Okay, what's 13 squared?
13 squared is 169.
169, good. What's 11 squared?
121.
121. That equals c squared. Okay, what's 169 plus 121?
169 plus 121 is 290.
290. 290 equals c squared. Now this happens to be 29 times 10. And what can you tell me about 29?
Well, these are not square. They're not square numbers.
Right. It's 29's prime, and 10 is 2 times 5. So there's no way to simplify the square root. So what does c equal?
C is the square root of 290.
Square root of 290. I don't know how well you know your square roots. There's a perfect square that's really close to 290. Do you know what it is?
No.
It's 17 squared, which is 289. So this is really close to 17, but it's not 17. It's the square root of 290.
Yeah, it's almost 17.
Almost 17. But now let me give you a tricky one. Okay? Let me give you a tricky one. Instead, we might know one side in the hypotenuse. So you're in a room and you say, well, it's 5 feet across and 13 feet from corner to corner. I want to figure out how tall the room is. Okay, what equation do you set up here? That's a b, by the way.
A squared plus b squared. A squared plus c squared. Well, it's...
What's the Pythagorean theorem say?
A squared plus b squared is c squared.
A squared plus b squared equals c squared. So what does that say for this triangle?
Well, it says that 5 squared plus b squared is 13. Is 13 squared.
13 squared.
It's 25.
25 plus...
Plus 169. 13 squared is 25 plus b squared.
25 plus b squared is 169.
So, I'm going to figure out what b squared is.
How do you do that?
169 minus 25.
Okay.
Which is 144.
B squared is 144.
Which means b is 12.
B is 12. Okay. So, in this special case, b was 12. Okay,
so only for right triangles.
Well, there's actually a more complicated rule for other triangles. You know what? Just for fun, I'll write down that rule in a second. But let's do one more of these for practice. So give me the side. Give me a leg, side. We're going to just keep calling this B. So give me the side of a leg and the length. Sorry, the length of a leg and the length of the hypotenuse. Just make up any numbers you want. Except the hypotenuse has to be longer than the leg.
How about 7 and 15?
Okay, great. What is our equation? What's the Pythagorean theorem say?
A squared plus B squared is C squared.
A squared plus B squared equals C squared. So what does that say for this triangle?
It says that 7 squared plus B squared is 15 squared.
Okay, what is 7 squared?
7 squared is 49.
49 plus
B squared.
B squared
is 225.
equals 225. Okay?
Well, 49. We have to do 49 minus 225 to figure out B squared. 225 minus 49.
225 minus 49. What is that?
Oh, it's 200. 20 minus 40 minus 20. Minus 9 minus 4. So it's 176.
Okay, sorry if that was off screen. I don't forget how low the screen goes today. B squared is 176. Now, do we know any squares that are 176? No, 13 squared is 169. But what can we factor out of this that's a square? Definitely.
You could factor out
4. So this is 4 times what? 4 times what is 176?
4 times what is 4 times something is 176.
That's true.
Yeah.
4 times what is 176?
Well, 4 times 40 is 160.
Yeah.
Then we got 60. So it's 4 times 50. 4 times. Let's just do the long division.
Okay, that's fine. So 176 divided by 4.
Alright, 17. Division to 17. 4 times 4 is 16.
Okay, 4 times 44. The funny thing about 176 divided by 4 is you only need 4s. Okay? And what is 44? 44 is
4 times 4
times
11.
4 times 11. So 176 is actually 16 times 11. And what's special about 16?
16 is a square.
So B is the square root of 16 times the square root of 11, which is
4 times
4 times the square root of 11. Okay, so this is a triangle that is 7. If the hypotenuse is 15, this is 4 times the square root of 11. So sometimes it doesn't work out so nicely. I mean, actually, that's not that complicated, right? It's just a square root. But it's not always integers. And for fun, you want to see the formula for a general triangle?
Yeah.
Okay. You're not going to understand it, but what the heck? Because it has this thing you've never ever seen before.
What?
Okay, so if you have a general triangle, let's call it A, B, C, like this. And you know what? I should actually do it the same as the Pythagorean theorem. I'll use A, B, and C. And if this angle here is theta, remember I told you math uses theta for angles a lot?
Yeah.
Okay, the formula is C squared equals A squared plus B squared minus 2AB cosine theta. That doesn't make any sense, does it?
I think I just saw this formula in a comic book.
You saw this formula in a comic book?
Yeah, I just...
What? What comic book has the law of cosines in it?
Oh, it's this Foxtrot one.
Oh yeah, of course, Foxtrot. So who had that? Was that Jason?
Yeah.
That's funny. That's funny that you've seen that before. Okay, well that's what it is. So, but anyway, don't worry about this. We're not going to talk about this for a long time. I guess unless you have to read Foxtrot. So that was good Pythagorean theorem practice today. High five. Boom. Boom, boom, boom.